All right, next for the random forest that we have generated, let's look at confusion matrix. It's slightly different here. So you do have RF, okay, confusion. Okay, so that gives you a brief look at the confusion matrix. So it just gives you that. It doesn't give you any other um, accuracy measures. Okay, this is for train. And if you want the whole thing, then you have to generate the prediction and then use the confusion matrix. And we will generate this only for uh, validation. Okay, so we have to predict using the random forest. Predict, okay, RF new data equal to valid.df. Okay, so random forest, that's it. You give these two, you get RF predict. Okay, so you have a factor that gives you everything. So then you can go straight into confusion matrix, RF pred, which is already a factor, and then the actuals, which is as factor valid.df personal loan. All right, so that will generate the confusion matrix with all the, and then again see positive class is 0, so you want positive equal to 1 will give you with the personal loan equal to 1 as our positive class. Now for ROC we have to generate the probability. So RF dot prob, right? Now this needs to be a data frame, so we need data frame, and then within that we do predict. Predict RF new data equal to valid dot df, right? And then we have to give type. Okay, the default type is class. So we say here sometimes uh, the base procedures use raw, but here it is prob. Type equal to prob will generate probability for us. Okay, and you put it in a data frame. Okay, so rf.prob. Okay, so you see x sub 0 and x sub 1. X sub 0 is for 0, personal loan equal to 0, and x sub 1 is personal loan equal to 1. So these two probabilities will sum to 1 obviously. So once you have the probabilities, and then we can do ROC, okay, the actual class valid.df personal loan, okay, and then the probability, so that is rf.prob, and we want probability of x sub 1, okay, and then we want to say plot equal to true, okay, and then say we want color equal to blue, so the line color will be blue, and line width, say we want 4% equal to true, so which means the x and y axis will be in percentages instead of going from 0 to 1, and we can say legacy axis equal to true, so you'll have x-axis will be 1 minus specificity instead of just specificity, and then we will do print dot area under the curve equal to true, and then we can specify where it should print AUC dot X equal to 40, print dot AUC Y equal to 40 as well, and you want it to be smooth, so we say true. Okay, so now that's our ROC. Now you see that ROC is not compact, and for that we have to specify par PTY equal to small. Okay, you run that and then you run your ROC, then it will be compact.